Mhm. Great. So, hello everyone, my name is Filip and I will be presenting our work in progress that is currently focusing on creation and actually extending the current capabilities of framework that we have already developed, and we are especially looking into interest aspects on how can we actually extend it to accommodate for large-scale distributed system evaluation. So throughout the interesting talk over the past sessions, we have definitely seen a lot of interesting aspects that when it comes, for example, to upgrades of blockchain protocols, when it comes to using different cryptographic primitives. And now the question is, how actually does it affect the blockchain itself? And for that, basically, we are looking into the ways on how to be able to assess them in a large scale, in a private network, and collect interesting insights. So to provide a bit more of motivation, so in general, we are looking into the ways on how to look not only into actually blockchains, but general cryptographic protocols, for example, like threshold cryptography, peer-to-peer systems, and also privacy-preserving networks. So we can also, for example, think of mixed nodes that were introduced yesterday in the talk of Daniel Hugenroth, and look into the ways how can we deploy them in our infrastructure, evaluate them in a reproducible manner, be able to actually compare the different architectures and their implication on the performance of the system, and of course try to identify common ground for evaluation without any external noise, which especially the last point is important. Why do we actually do it, for example, in our private infrastructure instead of using, for example, something like AWS, because of course it means that you will have a lot of external noise and you might be evaluating not only your assessment, but also part of the infrastructure that you do not know. And in general, we call it that we are looking into the ways on how to emulate realistic deployments in our setup. And of course, once we have this part in place, also important to motivation, why do we do it? And of course, the part is like once you are able to evaluate the base system, you can of course look into the ways how to look for improvements and optimization of the systems. So for example, if you want to integrate trusted execution environments into your system for certain use cases when it comes to private computing on permissionless blockchains, it will actually have some implications on the system. So you have to be able to understand what are those implications when it comes to performance, finality, and so on. Other part is we also had a very interesting talks with respect to MEV yesterday and how it can affect the security of the consensus. So there are also ways actually how these can be mitigated. But of course, introducing those can bring additional challenges when it comes to the performance. So again, being able to evaluate it if we introduce certain techniques into the system is very relevant. Smart contract overheads, already a couple of questions from the audience regarding that. So seeing what are the pros and cons with respect to that, it's very interesting, and protocol updates definitely as well to be able to assess these individual parts. So of course, for that, the framework will be a stepping stone that enables a lot of further evaluation and assessments. And throughout the talk, I'll be basically not talking about how did we solve all of the aspects of the deployments in large scale, but rather focus on the aspects on what requirements have we identified and how can we actually handle them for our deployments, because it's still a work in progress, and we are working on a publication that hopefully will be done after summer, so keeping us quite busy. Starting also a bit of the information, so we have seen on the previous slide something called engine. So also what is an engine, and actually we have tried to approach a slightly different problem with a similar way, where we were looking into the ways how can we assess time-sensitive networks that are used inside of industrial applications, inside of intravehicular networks, and so on. In general, TSN aims to offer deterministic behavior to Ethernet, and for that we have created this framework engine. That is also the part why it's coming because it's originated from the intravehicular use cases. We also call it engine to kind of be fitting the domain. But of course, we want to assess, and actually it's already something that we are convinced that the methodology that we have created that is part of this framework can be actually also applicable to the large-scale distributed systems. So just also for motivation, we have a couple of papers in case you're interested that are focusing on the usage of engine for the domain of TSNs, but definitely see a lot of potential on how to apply it also to the distributed systems. So starting a bit of information on how engine works. So in general, we assume that we have some form of management host, a data repository that you can think of like a central point, and you define there different type of information. For example, what is the traffic generator you want to use? You want to also use certain aspects about the data that will be actually later on shared in the network, and those later on will be used as an input that you define for the deployment of the system under the test. So in this thing, in the scope of our talk, we are mostly, for example, talking about how many validators will be in the network, how many subnets, how many mixed nodes, how many powerful signers, and so on, depending on what system we want to evaluate. And based on the information we provide as a part also, so for example, of the network topology and so on, we should be able to deploy all of these individual components inside of our network. And of course, later on, very important part is like we are actually collecting all of the individual data that later on will be used for the post-processing and evaluation of the individual metrics. And from that, we see that that actually a similar flow can be quite easily applied to distributed systems, right? At the end, we will be able to define how many nodes do you want to have in your system. Are we talking about relay nodes? Are we talking about participation nodes? Are we talking about validators? And this, of course, is very nicely applicable to blockchains. Are we talking also about how many transactions per second? So if the system has to handle certain load, we have to be able to assess that the load actually in the system can be handled. And basically, we see that with this level of abstraction, we are able to actually define the inputs properly to be able to assess the system in a reproducible manner and collect the individual insights. So this is great, already a stepping stone, because with that we have verified that our methodology that we have previously defined can actually be applied to different set of problems. But definitely we see that actually based on the original ideas that we had, we need to revisit some of the requirements, because when it comes to distributed systems, we are also talking about much, much larger scales, right? So we are talking about more than hundreds, sometimes even thousands of nodes that are globally distributed, which introduces a lot of aspects when it comes to, for example, different latency modeling in the systems. And we have a lot of configuration parameters that are not only applicable to a single blockchain, but as if you look into different permissionless blockchains, you will actually see that there is a lot of individual tweaks and considerations that were actually done to make the system work. So of course, all of these parts bring possible challenges I will be talking about in the more upcoming slides, but in general trying to identify also the various building blocks and try to later on identify, okay, this feature actually is very interesting and could be used in other systems, would be something interesting. So the general open challenge is like, how can we bring this huge beast of thousands of nodes that is running out there into a constrained local environment. Constrained I don't mean by hardware resources, by the, for example, amount of nodes, but still collect valuable insights. And of course, this requires quite a lot of research consideration when it comes to doing the proper mapping and proper modeling of the individual large-scale deployments into our private network. Looking back at our methodology of engine, we have defined several requirements that I think, when considering, as mentioned, can be applied also to the blockchain. So just in general, what are the requirements we were considering? So looking into the input and output properties, we of course want to make sure that we are actually working with realistic information. We are working with a lot of diverse information, and of course we want to make sure that the data that we collect are actually interpretable, because without that it will be very hard to collect insights for further evaluations. Then looking at the engine and the testbed properties itself, of course, we want to make sure that the experiments can run in a reproducible manner, autonomously, in the sense that you run enter and you will come few days later to collect all of the individual insights. Should be running scalable, in a scalable manner, meaning that actually you should have the control about the amount of information you are providing and the amount of nodes that you will be using, and configurable with respect to the different parameters. And finally, using the collected insights, you can actually assess the system reliability, but also security with respect, for example, to different network guarantees that your consensus, for example, if you talk about blockchains, can provide, and see if those are not held, how that actually affects the overall performance. So looking at on the left side, we basically have the requirements that for sure still are valid, and it's definitely part that we would say it's already there, but the part that actually needs a bit of revisit in comparison to the initial idea is, for example, scalability. So in the previous requirements, we are mostly focusing about the aspect of how much traffic are we generating. So in our previous scenarios, by traffic, we are, for example, emulating different type of sensors inside of the car, like cameras, LiDAR, and so on. But of course here in blockchain domain, it can mean many different stuff, which I'll be talking about on the upcoming slides. Same applies for diversity, interpretability, because you have much more different data sources, which means actually a lot of different data formats that you have to deal with. Configurability, because there is a lot of tweak and parameters you have to consider. And a big challenge is the aspect of realism, because as also discussed previously, for example, how do you get the real workloads into your system is something that we have to definitely consider to have a right view and the right mapping to the real infrastructure. Talking about the individual parts a bit more in detail. So for example, talking about scalability, it can of course affect the number of nodes. Like, do we have hundreds of nodes, thousands of nodes, and so on? So definitely this is something that we have to take into consideration. Other aspect is transactions per second, number of wallets, and all these parts that have to be taken into account. And overall, what we want to achieve is that actually our deployment should allow for the representation of such deployments in our local setup, and it should be actually achieved by having not only the theoretical understanding of the individual protocols and the consensus mechanisms to be able to map it properly, but actually having the real data to be able to map it correctly and use the right utility mechanisms. Talking about diversity, we see that each blockchain generates a different type of information that you can later on store for your processing. So you have different transaction formats, different log information, different type of network traffic as well. So of course you can try to generalize it in the direction of transaction blocks and votes, but maybe depending on the chain you can also have something a bit more exotic. You can also, in general, of course, have a lot of on-chain data, but you can also actually consider off-chain data. So for example, if you receive a transaction that is in your mempool, later on, maybe it will not actually make it into the on-chain data, so you don't want to lose the visibility on such type of data when you are doing an experiment as well, to be able to assess how, for example, powerful should be the corresponding node that you are using in your system to actually be able to scale the system properly. And what we have definitely found out already now with our work, each blockchain is very different when it comes to configuration capabilities, when it comes to the knobs and tweaks that you have to do in consideration to do it in a local deployment. And this is very interesting from the perspective of like looking into the internals of such a system, how they work. But of course, it's making our life a bit more difficult because we have to actually find the right approaches to be able to compare blockchain A with blockchain B on the same in a fair fashion, because otherwise the comparison can be quite misleading. Some BC, maybe this one. Yes. Yes. Perfect. And of course, in order to do the fair comparison, you have to understand very well how are the nodes structured. So for example, looking into several examples, some blockchains are relying, for example, on some form of subnets, some do not have this type of features, and how are we actually able to later on compare this stuff is very important. How the consensus mechanisms itself works, how the programming language itself work, and so on and so forth is very interesting with respect to the diversity, but it's really making it challenging in many ways. A very important part is the interpretability, because you want to collect the data from different sources that are distributed in your actually private network as well, and you have to be able to actually map that the information that you see on node A actually corresponds to the same information that you see on the node B, and be able to correlate this information to actually do a right assessment, for example, when it comes to calculation of network delays. But the same actually applies also to other properties, where you want to actually have some form of data fusion from different type of sources in order to be actually able to evaluate it. Big focus is also on the configurability, because as we know, when we look at the blockchain stack, we have the data layer, network layer, consensus layer, execution layer, application layer. Of course, all of these individual parts have quite vary between each of the individual blockchains when we look into the details. And it's important that the framework itself can actually support the various configuration that you see in the system. And for that, you also need to have consideration of different hardware specification. That will later on also allow you to actually collect the right insights. For example, if the system that we are looking into bottlenecked by CPU, or is it a network delay, or some other metrics that is actually causing the system to stall or not perform in a right manner. And similarly, if we talk about realism brought to to the private networks, we definitely have to consider something on the networking layer, because as we all know, when you have a direct connection between two PCs, it's very different when you are actually exchanging data in a global fashion, like blockchain, for example, aim to be deployed, where you have very different type of latency guarantees and very different behavior when it comes to packet drops. So all of these aspects have to be actually, we have to be able to configure to actually achieve the experiments to collect right insights. And last point when it comes to the requirements is realism. And as mentioned previously, we were taking, for example, data from actual deployments of cameras and LiDAR that are actually available inside of the intravehicular networks. So fortunately at TUM, there is quite a lot of possibilities and collaboration actually how to collect such information that can be later on replayed in the inside of your network, which is great. And actually similarly, you can do it for the blockchain as well. You can actually run your own information, your own infrastructure, your own nodes that are actually collecting the different information on your node that participates in the public chain. And later on, you can actually look into the characteristics of this given traffic and be able to deploy it locally. But of course, it's still posing a lot of challenges because you have to deal with the mass of information that you are dealing with, and for that you have to also identify what are important traffic patterns that you are looking for, what is the right workload to actually use in the system, and so on and so forth. But of course, again, going back to the previous point, each blockchain actually behaves slightly differently. So what blockchain do you use as a base for actually defining the workloads? Do you collect... I don't know why it is, yeah, perfect. Yeah. So what blockchain do you use as a base? Do you use for example, Ethereum? Yes, it's very good. Of course, it's a good base. It's very frequently used system, but maybe you are missing some of the features that actually are happening on some other blockchains. So of course, in that sense, it's something to consider when it comes to the realism aspect. And additional type of traffic that we can of course see is, for example, when we look into the consensus and other aspects is, for example, how the governance, tokenomics, and other parts affect the system, because you also want to make sure that actually in the real system you have most likely, when we talk about proof of stake systems or about proof of work systems, we have different type of computational power or different type of stake in the system that actually also affects the likelihood of being, for example, selected to participate in the consensus. So of course, these parts also have to be mapped properly to our system. And this last part, of course, is the network behavior. So fortunately, there is already quite some work done with respect to how you model global networks in your private networks, but of course, having the capabilities to actually configure such system in your local deployments is very, very interesting. So to summarize, we see there is several open challenges when it comes to actual deployments of large-scale systems into our infrastructure. We believe that we have actually found quite a good compromises when it comes to that. Overall, what is a little bit also interesting to see is that there is not really a unific evaluation or comparisons when it comes to assessing of different metrics in different blockchains. So we can, of course, look into transactions per second. We can look into finality, but are we talking about finality when actually the blockchain is settled, the transaction is fully settled and it cannot be reversed? Or are we talking about rather latency when actually we can use the information already, but the transaction is not final yet? So there is also not a clear definition of all of the individual metrics that we are looking into. Again, this makes our life more interesting because it's fun to basically try to find the unifying metrics, but it's of course very important with respect to the evaluation of different ecosystems, for example. And overall, we believe that our framework is a very interesting stepping stone to achieve the holistic view on the interaction of individual blockchain layers, because we should be, and we have the control actually over the individual aspects of the blockchain stack itself. So hopefully it can help us to develop a new generation of core developers that will be able to actually handle the complexity which we talked about, and partial also as a part of the TUM blockchain saloon. We were looking into how the individual blockchain layers work, and maybe this tool can help with new ideas that can be brought together and evaluate them in a unified fashion. So of course, a lot of new cryptographic protocols are being developed, or there are recent publications that aim to improve the performance or be used for specific use cases. Threshold cryptography is one of them, trusted execution environments, very interesting topic as well when it comes to layer 2 solutions, privacy preserving networks, and so on, that of course can have a significant impact on the system itself. So with that, with our framework, we believe that we are able to collect the individual insights from all of the individual parts. And just a last slide with respect to cross-stack collaboration. So I think also, as we have seen throughout the last several sessions, there are many different views when it comes to the usage of blockchains. And as Professor Kyle was also mentioning during the panel, I think it's hard to be a domain expert in all of the fields, but it's important to know where the interesting questions lie, and an example for that is, for example, the MEV. That is quite a nice combination of tokenomics, security guarantees, and also actually the underlying network and consensus approaches together. So definitely it's good to have expertise from different layers. When it comes to private computing, it's very interesting also from the usability aspect of actually what applications could benefit from having such capabilities on the blockchain, and also from previous talks, for example, aspect of simulation versus emulation of different parts that can be either integrated and improve the emulation of the network, or the other way around, actually the data that are collected in real networks can later on enhance the capabilities of the simulator itself as well. So a lot of interesting parts, and the one that I think we also touched briefly yesterday during the panel was the aspect of use cases and identifying maybe right blockchain for the right use case. So is it the way how it should be, or will it be multiple blockchains? Most likely yes, right? And they will all of them have slightly different properties that might be actually fitting your specific needs. So overall, a very exciting topic, and looking forward to make our framework a bit more usable. And in case you have any questions, feel free to reach out, and we'll be happy to also, if you want to contribute, because the framework itself is actually open source, and we are always adding new features once we see that there is something worthwhile to share with the audience. So in case you're interested, feel free to reach out. Thank you very much.